On this one, we're going to determine the absolute maximum and absolute minimum if either exists for the function f of x equals 9x cubed minus 54x squared plus 81x plus 13 on the interval from -6 to 2. Now, this particular question asks specifically about, again, absolute, not necessarily local max-min, though they technically can fall in the same place. Absolute max and absolute min, we go about finding them in a different but somewhat similar way to what we would do for local maximum and local minimum. The first thing we're going to do here is we're going to find the derivative, solve equal to 0, to find the critical numbers. So in this case, f prime of x would be equal to 27x squared minus 108x plus 81. So we're going to need to solve that derivative equal to 0. When I look at all this stuff here, I can see there's a GCF that's actually 27. If we factor out the 27, we can write it as x squared minus 4x plus 3 is equal to 0. And we can actually continue from here to factor it some more, because it will factor to x minus 1 times x minus 3 equal to 0. A quick way of telling, and this is the shortcut factoring here we use, is that -1 and -3 both multiply to +3, and they both add to -4. So what we can do now is set each of our factors equal to 0, and we'll solve to get x is equal to 1 and x is equal to 3. Now the next step is to plug in the critical numbers and the numbers at either end of the interval into f of x, which is the original function, not the derivative. So when we go back up here to the original function, it gave us the interval from -6 to +2. We're going to plug the -6 and 2 in, along with our critical values we have here. So if we do that here, starting with f of -6, that'll look like this here. I came out with -4,361 when I plugged in the -6. Now let's go through and plug in the 1, the 2, and the 3 and see what happens with those numbers inside the function instead. When I plugged in 1, I got 49. When I plugged in 2, I got 31, and when I plugged in 3, I got 13. So the largest of all these numbers is the 49. That would be called the absolute maximum for our function. The smallest number of all of them is the -4,361. We'll call that the absolute minimum of the function.